Let's start problems on Faraday law, students. Most important, all JEE PYQs these are. This will cover neat board everything. See, consider the following reaction. MnO4 minus converted into Mn2 plus. So here how many electrons are accepting? 5 electrons. So MnO4 minus, if you take oxidation state of Mn is plus 7 here, converted into Mn plus 2. So here the difference is what? 7 minus 2 is 5 electrons. That's what they have written here itself. So to deposit 1 mole of Mn plus 2 from 1 mole of MnO4 minus, 5 Faraday or 5 mole of electrons are required. So 5 Faraday can deposit 1 mole of Mn plus 2 from 1 mole of MnO4 minus. Now they are asking how many Faradays required to deposit 5 mole of MnO4 minus 5 Faradays. For 5 moles means 5 into 5, 25 Faraday required to convert 5 mole of MnO4 minus 2 to 5 mole of Mn plus 2. So just here to deposit 1 mole of M from M power or M plus X. So whatever the charge is there, whatever the oxidation state of metal is there, that many Faradays required to deposit 1 mole of metal from that oxidation state. Example, Al plus 3. If you want to deposit 1 mole of Al plus 3, 3 Faradays are required, which is also same as 1 mole of Mg2 plus. If you want to deposit, 2 Faradays are required. Same way 1 mole of Na plus, if you want to deposit, you need 1 Faraday, which is also written as 3 Faradays gives 27 grams of Al, 24 grams of Mg, and this will be 23 grams of Mg. That's how the number of Faradays versus mass of metal deposited. Coming to next question. A solution of Fe2SO4 thrice is electrolyzed for X minutes with current is given and mass of iron also given. So here the directly formula based. Mass of metal deposited equals to molecular mass by N factor or oxidation state of metal IT by Faraday. So here metal mass is given 0.3482 grams, which is equals to molecular mass is 56 by oxidation state of iron in Fe2SO4 thrice is 2x plus 2 irons are there, 2x plus 3 into SO4 is minus 2 iron, which is equals to 0. So 2x minus 6 equals to 0, x equals to plus 3. So 3 we can write it into I value is 1.5 ampere, time you will get in seconds by 96,500 coulombs. So T you will get it as 1200 seconds. So if you convert this into minutes, so by 60, which is equals to 20 minutes. This is the answer for this question, students. Hope it is clear. Coming to next, the quantity of electricity needed to reduce 1 mole of Cr2O7 minus 2 to Cr plus 3. So how much it will be, we can discuss. Very simple question as like first question. So 1 mole of Cr2O7 minus 2 converted into 2 Cr plus 3. So here oxidation state of Cr will be plus 6. If you want you can write it 2x plus 7 into each is oxide. So oxidation state minus 2 equals to minus 2. So 2x minus 14 equals to minus 2. So 2x equals to 14 minus 2, which is 12. So x equals to 12 by 2, which is equals to 6. So to deposit or to make electrolysis of 1 mole of Cr2O7 minus 2 to Cr plus 3, 6 Faradays are required. So answer is what, students? 6F. Hope it is clear. Now we'll discuss one more question. So 108 grams of silver is deposited at cathode from AgNO3 solution. It's AgNO3 by certain quantity of electricity. Volume of oxygen gas produced at 273 kelvins and 1 bar pressure from water, same quantity of electricity. That is important. This only the clue point from this how to decide. So I have given all the related information in before lecture. So if you have any confusions regarding this, you can watch that video. Surely it become much easy. See here, to deposit 108 grams of Ag from AgNO3. AgNO3 means the charge of Ag is +1. So to deposit 1 mole of Ag, 108 grams means 1 mole of Ag from Ag plus. Need how many Faradays? 1 Faraday, because charge is 1. So 1 Faraday is required to deposit 108 grams of Ag from AgNO3 or Ag plus electrolytic solution. So we got to know that the charge is just 1 Faraday. We already discussed to deposit 1 mole of O2 gas. How many Faradays required? 4 Faradays. How to decide? I have given one shortcut trick for this. O minus 2, O minus 2, you write it. Because we know that oxygen is -2 ion. Just you break those two oxygens as like this. It won't be technically, just for remembering. So how without charge you just add those two. 2 plus 2 is 4. So to deposit 1 mole of O2 gas, 4 Faradays are required. So accordingly, if you use 1 Faraday charge, how many moles of O2 gas will be deposited? Just you have to do cross multiplication, right? If you do it, 1 by 4 mole of O2 will be O2, 1 by 4 mole of O2 will deposit. So they are asking volume, right? So volume how to convert? So 1 mole of O2 gas is nothing but 22.4 liters of O2 gas is deposited. For depositing 1 by 4 mole of O2, volume of 1 by 4 mole of O2 is nothing but what? 22.4 by 4, which is equals to 5.6 liters. Hope it is clear, students. So 5.6 liters of O2 will get deposited. That's how we can do this question. Same way, here we can see the question. An acidic solution of dichromate is electrolyzed for 8 minutes and 2 ampere current as per the equation. So equation is same like before question. Cr2O7 minus 2 to 2 Cr plus 3. So amount of Cr plus 3 obtained was 0.104 grams. The current efficiency of the process is. So current efficiency will be how much? So what we have to do here is, see from the equation, to deposit 2 mole of Cr plus 3, 2 mole of Cr plus 3 from 1 mole of Cr2 plus Cr2O7 minus 3 to, like Cr2O7 minus 2 converted into Cr plus 3. In this, the oxidation state of Cr is +6 converted into +3. So the difference is what? Each one 3 difference, but how many chromiums are there? 2 are there. So together how many Faradays required? 6 Faradays. So 6 Faradays required to convert this process. We can also tell the same point. 6 Faradays required. 2 mole of Cr plus 3 means 2 into 52 grams. So to deposit 2 into 52 grams of Cr from Cr2O7 need 6 Faraday charge. 6 Faradays can also write it as 6 into 96,500 coulombs. Now come back to the question. They have given charge value, which is 8 minutes, 8 into 60 into 2 amperes. So 8 into 60. So what you will get is 2, which is equals to 120 into 8, which is equals to 960 coulombs. So this many Faradays or this many coulombs use this many grams of Cr. Now 960 coulombs means how many grams of Cr will be deposited. So you can write it, 6 into 96,500 coulombs gives, so 104 grams of Cr. And for 96 coulombs how much? So 96 by just cross multiplication into 104 grams. If you simplify this, you will get 0.173 grams. But actual mass is what, students? Here this is supposed to be deposited with this charge 960 coulombs, but actual deposition value is less than this. What is the actual deposition amount? 0.104 grams. 104 grams is deposited instead of 0.173 grams. So the current efficiency is not 100%. So how to calculate that? So this we can also tell it as theoretical mass, and this is called as actual mass of metal deposited. So formula for this is efficiency equals to, or current efficiency equals to 0.104 by, that is called as what, actual mass by theoretical mass, 0.173 into 100, which gives 60 percentage. So the efficiency formula you can write it as W actual by W theoretical into 100. So if you do it, you will get 60 percentage is the answer. Hope it is clear, students. So you can solve this question. Just amount of charge required to obtain 1 mole of iron from Fe3O4 is. Just solve this. It's also very easy. And message answer you put it in comments. Thank you. Hope it is clear. Please like and subscribe. Refer to your friends, so even they will get benefited. Thank you. If you like it, it will be good motivation for me to make more this kind of videos. Thank you.